For centuries, the Sahara Desert has been synonymous with desolation. An immense, scorching expanse of sand and rock, stretching across North Africa, it is the world's largest hot desert. Its vast, seemingly barren landscape covers an area of approximately 3.6 million square miles, almost the size of the United States. This formidable environment has long been perceived as a timeless, unchanging wilderness, a monumental barrier to life and human passage. But what if this iconic image is merely a snapshot in a much longer, far more dramatic story? Modern scientific inquiry, however, is challenging this perception, revealing a startling truth: the Sahara Desert was not always a desolate wasteland. Evidence suggests that a mere 5,000 to 10,000 years ago, this very region was a vibrant, lush, green paradise. Imagine vast grasslands, sprawling savannas, and extensive forests teeming with wildlife, nourished by massive rivers and colossal freshwater lakes. This dramatic transformation, from a verdant Eden to the arid desert we see today, is one of Earth's most profound and relatively recent climate shifts. The scientific community refers to this period as the African humid period, driven by predictable astronomical cycles known as Milankovitch cycles. These cycles influence the Earth's orbit and axial tilt, altering the distribution of solar radiation and, consequently, global climate patterns. During this phase, increased monsoon rainfall transformed North Africa. What once received minimal precipitation suddenly became fertile, allowing diverse ecosystems to flourish. This climatic shift wasn't a slow, gradual process over millions of years, but a relatively rapid one, changing the face of a continent within millennia. How do we know about this verdant past hidden beneath millions of tons of sand? The answer lies in the skies above. Modern satellite technology has become an invaluable tool for what researchers now call satellite archaeology. Utilizing radar, infrared, and spectral imaging, scientists can penetrate the shifting sands, revealing geological features long buried and invisible to the naked eye. This innovative approach has led to groundbreaking discoveries, sketching a remarkably detailed picture of an ancient hydrographic network that once crisscrossed the Sahara. Among the most significant revelations are the traces of vast, ancient river systems. According to a 2013 study published in the journal Nature Communications, researchers identified a colossal paleo river, dubbed the Trans-African River or Tamanrasset River, which once flowed over 600 miles from the Atlas Mountains across the Sahara to the Atlantic Ocean. This and other intricate networks, such as the Kufra River system in Libya, were not mere streams but mighty waterways, comparable in scale to the Nile, capable of sustaining diverse ecosystems and potentially human populations. Complementing these river systems were immense freshwater lakes, some rivaling inland seas. Perhaps the most well-known is Lake Megachad, which, during the African humid period, was significantly larger than any contemporary lake in Africa, covering an estimated 400,000 square kilometers, an area larger than the Caspian Sea today. Such massive bodies of water would have created fertile habitats, supporting rich flora and fauna, and serving as critical hubs for early human activity. These ancient lakes were not isolated phenomena but part of an interconnected aquatic landscape. Among the Sahara's most enigmatic features is the Rikat structure, often called the Eye of Sahara. Located in Mauritania, this colossal geological formation is a deeply eroded dome, approximately 30 miles in diameter, displaying a striking bullseye pattern from space. For decades, its precise origin puzzled scientists. Its near-perfect circularity and immense scale led many to initially theorize it was the remnant of a colossal meteorite impact. However, further detailed geological studies began to paint a different picture of its formation. Today, the consensus among geologists, supported by research from institutions like the University of Arizona, suggests the Rikat structure is not an impact crater, but rather a highly symmetrical and deeply eroded domal uplift. It is believed to have formed when magma pushed towards the surface, creating an upward bulge in the Earth's crust. Over millions of years, subsequent erosion stripped away the overlying rock layers, exposing the concentric rings of different rock types. This process, while understood, still leaves the question of its remarkable circular symmetry as a subject of ongoing scientific interest and debate. Beyond its geological significance, the Richat structure has ignited fierce speculation regarding its potential link to the lost city of Atlantis. Theorists point to the remarkable parallels between Plato's description of Atlantis in his dialogues Timaeus and Critias and the Eye of Sahara. Plato describes Atlantis as a civilization built on concentric rings of land and water, surrounded by a great plain, situated near the sea. The Richat structure's circularity, its position within a vast, formerly green Sahara, and its size, align uncannily with various aspects of Plato's ancient account. While the visual similarities between the Richat structure and Plato's description are compelling, it is crucial to approach such claims with scientific rigor. As investigative journalists, we must note that there is currently no archaeological evidence found within the Richat structure that unequivocally supports the existence of an ancient, advanced civilization. The geological processes that formed it predate any known human civilization by millions of years. However, the tantalizing correspondence continues to fuel discussion and research, prompting questions about the extent of ancient knowledge and the possibilities of undiscovered history. As if a green Sahara and a potential Atlantis were not astonishing enough, one of the most compelling pieces of evidence for the Sahara's aquatic past lies in a remote valley in Egypt, known as Wadi Al-Hitan, or the Valley of Whales. Here, in what is now an utterly barren desert landscape, paleontologists have unearthed hundreds of fossilized skeletons of ancient whales, some remarkably complete. These discoveries offer irrefutable proof of a marine environment that once thrived where now only sand prevails, challenging our very conception of this vast desert. The presence of these marine fossils in the middle of the Sahara is explained by a profound geological history. Millions of years ago, during the Eocene epoch, the region that is now North Africa was submerged beneath a vast, shallow ocean known as the Tethys Sea. This ancient sea was home to a diverse array of marine life, including early forms of whales. Over immense geological timescales, continental drift and uplift caused the Tethys Sea to recede, eventually leaving its seabed exposed. This process, coupled with subsequent erosion, brought these incredible fossilized remains to the surface. The fossils at Wadi Al-Hitan are not just numerous, they are incredibly well preserved and diverse. Among the most prominent are the skeletons of Basilosaurus, an early whale species that grew up to 65 feet long, still possessing hind limbs, remnants of their land-dwelling ancestors. Alongside these giants, researchers have also uncovered fossilized manatees, sea snakes, sharks, and crocodiles, painting a vivid picture of a rich coastal ecosystem. These finds provide invaluable insights into whale evolution and the dramatic environmental shifts that shaped our planet. The transition from a lush, green Sahara back to a desert was remarkably swift, occurring over just a few thousand years. Around 5,000 years ago, as the Earth's orbital parameters shifted, the monsoon rains that nourished North Africa began to weaken and migrate south. This change initiated a feedback loop. Shrinking vegetation cover led to increased surface reflectivity, which reduced atmospheric moisture and further suppressed rainfall. What resulted was a rapid desertification event, turning vibrant ecosystems into the arid landscape we recognize today, displacing or extinguishing untold life. Given the evidence of a green, fertile Sahara with vast river networks and massive lakes, it stands to reason that this environment would have supported substantial human populations. If the Sahara once boasted resources comparable to regions known for early civilizations, could there be entire cities or settlements buried beneath its sands? Theoretical models suggest that organized societies, perhaps even early kingdoms, might have thrived in this ancient paradise, leaving behind traces that are now hidden by hundreds of feet of sand, awaiting discovery. The search for these theoretical lost civilizations is fraught with immense challenges. The sheer scale of the Sahara, combined with the depth of the sand dunes and the relentless forces of wind erosion and deposition, makes conventional archaeological exploration nearly impossible. Unlike sites in shallower deserts, many potential Saharan settlements could be buried under vast quantities of sediment accumulated over millennia. This necessitates advanced techniques like ground-penetrating radar and seismic imaging to peer beneath the surface, transforming archaeology into a high-tech endeavor. While definitive lost cities remain theoretical, the Sahara has undeniably yielded rich evidence of early human presence during its humid periods. The stunning rock art of Tassili Eniger in Algeria, for instance, depicts scenes of daily life, hunting, and pastoralism, showcasing elephants, giraffes, cattle, and even swimmers, all clear indicators of a very different, wetter environment. These ancient frescoes, dating back thousands of years, serve as a direct window into the lives of people who once thrived in what we now perceive as an uninhabitable desert. Further testament to sophisticated early human activity comes from Nabta Playa in southern Egypt. Here, archaeologists uncovered one of the world's earliest known astronomical alignments, a stone circle predating Stonehenge by thousands of years. Dating back approximately 7,500 years ago, these megaliths indicate a surprisingly advanced understanding of the cosmos and a settled lifestyle in a region that was then fed by seasonal lakes and rains. Such structures suggest communities engaged in complex planning and observation, hinting at organized societies in what we assume was merely a prehistoric wilderness. The Sahara Desert, often seen as a static, desolate landscape, is continually revealing itself to be a dynamic canvas of Earth's history. From satellite images exposing forgotten rivers to ancient whale skeletons and mysterious geological formations, each discovery adds another layer to its compelling narrative. It serves as a powerful reminder that our planet's surfaces are constantly transforming, influenced by forces far beyond our immediate perception. The true extent of what lies hidden beneath its vast, shifting sands remains a profound and exciting mystery. In conclusion, the Sahara is far more than just sand. It is a living museum of Earth's past, a testament to dramatic climate shifts, and a potential tomb for forgotten civilizations. The evidence of a vibrant, green past challenges our assumptions and expands our understanding of human history and environmental resilience. As technology advances and scientific curiosity deepens, the Sahara will undoubtedly continue to surrender its secrets, offering invaluable lessons about our planet's capacity for change and the incredible, often surprising, stories hidden just beneath the surface. What other wonders await discovery?